built in the shape of a sinusoid. You have been hired to calculate the lengths of the horizontal and vertical timber supports to be used. Okay, so the vertical timbers are these vertical lines that you see on a roller coaster. Okay, and the horizontal timbers are the horizontal lines that you see. Okay, these are called timbers. The first question says the high and the low points on the track are separated by 50 horizontally and by 30 meters vertically. All right, so as you can see, the highest point is right here. The lowest point is right here. And the distance between those points in horizontal measurement is 50 meters. The vertical distance between these horizontal measurements is 30 meters, as you can see here. Okay, and it says the low point is 3 meters below the ground, right? So this low point is 3 meters below the x-axis on this graph. Letting y be the number of meters the track is above the ground and x the number of meters horizontally from the high point, write an equation expressing y in terms of x. Okay, so first we need to derive a sinusoidal equation. Okay, we know that it's denoted like this: a sine b times x minus c plus d. So let's find the individual components. First, we're going to find the absolute value of a. A is the amplitude. Okay, so the absolute value of a, the amplitude, as we know, is half the distance between the highest point and the lowest point. All right, the distance is 30, right? So we take 30 and divide it by 2. So that's going to be equal to 15. Okay, so notice that the true value of a is also 15 because we know that the sinusoid parent function begins from the origin, but we can treat the beginning of the sinusoid to be starting somewhere here, okay, on the midline. So there's a midline which is halfway from the lowest point to the highest point, right? It's going to be right in the middle, so that's where the sinusoid will start, okay? All right, so a is 15. Now let's find the value of b. We understand b by taking 2 pi, dividing it by b, and then setting it equal to the period. All right, now how do we determine the period? We know that 50 meters is exactly halfway to the period, right? It takes half the period, 50 meters. How do I know that? Because I know in a regular sinusoid, the highest point to the lowest point is going to be exactly half the period, right? So the full period is going to be 2 times the 50, right? So it's going to be 100. If you solve for b, that means 2 pi divided by 100 is b, which means it's going to be pi over 50. Okay, so b is pi over 50. Now, what is going to be the c value? The c value is responsible for moving the graph horizontally. Okay, horizontal shift. Is there a horizontal shift? Yes, there is, because we know that half of the period takes 50. We know quarter of the period takes 25. And we know that we have to start a quarter before the 0 point here, before the x begins to be positive, right? So we know that at x equals minus 25 is where the sine wave begins. Okay, it's going to be on the midline when x is negative 25. So we know we have to shift the graph 25 units. The parent sine function will be moved 25 units to the left. So the c is going to be minus 25. Okay, and now finally the d value, which is also corresponding to the midline, will be where the midline is. Okay, how do we determine that? First, we're gonna take 30 and we're gonna divide it by 2. All right, so first we have to divide 30 by 2. I'm gonna get 15. Okay, But be sure that you understand that 15 is not where the midline is, okay? The midline is going to be right between these two, the lowest and the highest points, okay? 15, if we assume that it's 15, we would be wrong because it should be lower than 15 since the lowest point is not right at the y value of 0, but it's 3 units below the x-axis, right? So we have to subtract 3 to compensate for that, right? Because we're going 3 units. So the midline, if let's say we count it from 0 to 30, the midline would be 15. However, it's not from 0 to 30, it's from negative 3 to 27, right? The highest point is 27 because we're shifting 3 units below the x-axis. So we have to subtract 3, and as a result, this will give us 12. All right, so the d value is 12. The midline is at the y value of 12 as well. All right, so now we know the complete equation, which will be 15 sine b is pi over 50, and then x minus negative 25, so we have to add, right? Two minuses give us positive 25 plus 12 plus the d value. All right, so this is the equation that you've successfully found using understanding of what these constants a, b, c, d imply. All right, so now the second part. Okay, and notice we expressed y in terms of x. Now the second part says, how long is the vertical timber at the high point? What does that mean? This is the high point. We want to find the length of this vertical timber. All right, how do we do this? We just plug the x value of 0 here, because that's what the x is here, 0, and see what the y yields. Simple as that, right? So let's determine that. So we're going to do y equals 15 sine pi over 50, and then take the 0, because that's where the x should be plugged in, plus 25 plus 12. All right, so that's going to be what? That's going to be 15 sine. Now 25 is going to be there. It multiplies the top, so 25 divided by 50 is 1/2, so that means it's pi over 2. All right, plus 12. So that's going to be what? That's going to be 15 times sine of pi over 2 is 1, right? So it's basically going to be 15 plus 12. And remember how I just said, using the logic of the shifting, that the highest point should be 27 and not 30, because we're moving 3 units below the x-axis, right? So that's precisely what the highest point is, 27. Okay, 27 meters. Yeah, because this is a word problem, we have to be very careful with that. All right, that's only one question. It says, what about when x is equal to 4 meters? Notice we plugged the x value of 0. Now we're going to plug the x value of 4 and see if that changes anything at all. So we're going to plug in 4 this time. Notice that x is the number of meters, right? Everything is in terms of meters, the x-axis and the y-axis. All right, so let's see what we get. So that's going to be 15 sine, that's going to be 29 pi divided by 50. As you can see, this is not going to be a whole number because we don't know, except on the calculator. We're going to have to look it up and see what we get as a result. So if you use your calculator, and be sure that you're in the radian mode when you calculate your sine, then multiply by 15, then add the 12, you should get something like 26.5 meters, rounded to the nearest tenth, of course. Okay, now notice it makes sense, because 4 meters to the right of that x value of 0, notice that there's a decline, right? There's a decrease in height. So it makes sense that it's not going to be the highest point. Now it's going to be lower than that and not higher than that, right? So it should make sense that it's 26.5 relative to 27 because you have a decline. All right, now 32 meters. Let's check that. 32 meters. Notice that there is a breaking point. This is the ground level. and 50 meters is already below the ground, where the y value is negative already, right, below the x-axis. But this is where the y value is 0, but I have a feeling that 32 will still be before that, before this breaking point. So let's check that. So we should get a positive y value still. That's my belief. Okay, so let's plug that in. So I have sine pi over 50, and then I have 32. I'm plugging into the x plus 12. So I'm going to get sine of what? That's going to be 57, right? So 57 pi. Notice again, we would need a calculator for this. There's no way to avoid it. All right, so if you round to the nearest tenth again, you should get the answer of 5.6 meters. Okay? Now the last part, part C, what does that say? It says where does the track first go below the ground? Okay, where does it first go below the ground? So notice that this is the breaking point at which it goes below the ground right there. But we don't have the luxury to check the x because we are looking for the x precisely. We know the y value though. The y value is 0. And precisely where tells you the x value, right? You want to find the horizontal distance at which it happens, right? You want to find the x value here. So we know the y value is 0, so we're going to plug those 0 instead of this y and try to solve for x. All right, so x remains this time. All right, now how do we do this? How do we do this? First, we're going to subtract 12 on both sides, right? So it's going to be negative 12 is equal to 15 sine pi over 50, and then x plus 25. And then, of course, we're going to divide both sides by 15. So if you do negative 12 over 15, it's the same thing as negative. You divide both by 3, right? So it's going to be negative 4/5. Negative 4/5 is equal to sine pi over 50 times x plus 25. Okay. All right, so now, how do you solve for this x? You got to get rid of the clutch of that sign. To get rid of that sign, don't divide by sign, okay? You have to take the arc sine of both sides in order for this to be free, the angle. So that means pi over 50 times x plus 25 is equal to arc sine, inverse sine function of negative 4/5, right? That's the only way to get rid of that sign, is to take the inverse sine of both sides. That gives you the angle that's free on one side, and on the other, you just have to keep it as showing arc sine of negative 4/5. Okay, so now notice we only need to find one instance of that angle, because we know that arc sine gives you two possible angles at which the sine value is the same. Okay, so two possible angles exist x such that the sine of that will be negative 4/5. But in this case, we only want one such angle and not the other. Okay, so now how do we do this? Notice there are two possibilities here. So on the unit circle, if you try to find arc sine of negative 4/5, the calculator will give you this angle, right? Because the sine is clearly negative, such that the angle for which the sine is negative 4/5 is true, right? So negative 4/5 is going to be in quadrant 4 for the sine. However, we want if we want a positive version of that, right? A positive version. If you go all the way around the circle to land at the same point, you will miss the first instance at which the same sine value happens, right? Which is going to be in quadrant 3. All right, and notice that that's the first instance it goes below the ground because it stops at the lowest point and then goes back up again, the sine function, right? And that will be the second instance at which the ground level will be reached. And that is corresponding to this angle right here. That is the angle that your calculator will give you. And that's a wrong angle because that's the second instance. We need the first instance, the first positive angle x at which it will happen. And that will be not the calculator, but this one. How do we find that? Notice we can use a very good formula. We know that the sine x is the same thing as sine pi minus x. Make sure that you understand it. So what that means is that we can easily, once we know this angle, we can easily find another one by subtracting that angle from pi. So what that means is that instead of using this, cross it out, because it will give you the wrong angle, which is that angle, but we should need this, right? So how do we get this angle? We get it from this formula. So namely, we said pi over 50 x plus 25 is equal to pi minus the arcsine of negative 4/5. Okay? Pi minus that angle, right? Minus this angle, minus that angle. If you subtract this from pi, okay, you will wind up here. Okay, that's the formula to find the second angle at which the sine value is the same. In this case, negative 4/5. Sine value of both of these positions will be negative 4/5. But one of them is correct and one of them is wrong in the context of this problem. Okay? So once you solve that, you of course distribute this. So it's going to be pi over 50x. 25 over 50 is 1/2, so pi over 2 equals pi minus arcsine of negative 4/5. Okay. So now you just have to subtract the pi, of course. So basically what you're going to have is going to be pi minus pi over 2, so that's going to be pi over 2 minus the arcsine of negative 4/5. So x will be determined by multiplying this whole right side by the reciprocal 50 over pi, right? That makes the 1x. So x is going to be the reciprocal 50 over pi times this whole expression, pi over 2 minus arcsine of negative 4/5. Okay, so if you do this carefully, make sure that you're going to be in the radian mode here. Make sure when you calculate arcsine of negative 4/5, you're in the radian mode because you're dealing with pi's, right? That's radians. So if you do this and you multiply then that result, first you find the arcsine of negative 4/5, negate that answer, and then add the pi over 2, then set equal, and then multiply by 50 divided by pi. So once you do that successfully, what you should get is about 39.8 meters. All right, so that's the x value, the distance from the origin, horizontal distance, at which the first instance of it going below the ground occurs. Okay? And again, notice that it makes sense because that is less than 50, right? 50 is exactly where the low point is. 39.8 makes complete sense with where this point is at. If you use the wrong answer, if you use this expression and solve for x without failing to subtract from pi, you would have gotten this point, which would be way above 50, right? So you can experiment that on your own. Try to solve this thing for x, and you will get something greater than 50. In fact, you should have the same distance away from the 50 as the 39.8. So you would get probably something like 61-ish for this if you solve this. Solve this for yourself and see if you get 61-ish for x, and you will see why this was rejected and how I talk to you about the unit circle and whether that makes sense and how to understand that using this formula to find the second angle. Thank you so much for watching. I'll see you in my other videos.